Okay, section 6.2, still dealing with vectors. First of all, we're going to look at what's called the dot product of vectors. And if you have vector u, so they're just referring to the components as u sub 1, u sub 2, and you have vector v with components v sub 1 and v sub 2. If you're asked to do dot product, okay, so it does use a dot like multiplication, but it's referred to as dot product, then all that you have to do is take the first component from each of those vectors and multiply those, and then take the second component from each vector, multiply those, and then add those two products together, and you will have what's called your dot product. Okay, so for this first example, I have vector 3, 4 and vector 5, 2. Alright, so finding your dot product, take first component from each vector, so that would be 3 times 5, and then you're going to add to that the product of your second components, so that would be 4 times 2, so we have 15 plus 8, which will give us 23. So 23 is going to be what's called your dot product. Now we'll use dot product to do a couple of other things here in this lesson. Alright, so one of the things is being able to find the angle between vectors. Okay, so if you have any two vectors, and you don't have to draw off what I'm fixing to show you, just so what I'm fixing to say makes sense. If this is vector u and this is vector v, you want to know the angle that is formed, the angle between those two vectors. Okay, so this would be an example of, you know, what it may be talking about, or this may be, you know, what it's talking about. So that's what this particular formula does for you. Now, you are finding these between 0 degrees and 180. And of course, the reason why it doesn't go any more than 180 degrees, because 180 would mean these two vectors are just end to end, making that straight line. Okay, so in that case, going from one vector around to the other would be exactly 180 degrees. So your answer is not going to be any larger than that. Of course, that would mean, you know, as far as a measurement, it would be something that would fall like a, you know, first quadrant or a second quadrant type angle. Anything between 0 and 180. So this is your formula. Okay, so this will always be cosine. You'll do the dot product in your numerator. So that's why we went over that first. Now from 6.1, we learned that this meant magnitude. So you'll have to go back and do the magnitude of the two vectors and then multiply those together. Okay? Okay, so here's the first example that we're going to look at. So find the angle between these two vectors. Alright, so just kind of breaking it down in steps here. First of all, in the numerator, we do need the dot product, so let's just go ahead and find that. So you multiply your first components together, so 2 times negative 2 plus 3 times 5, so that's going to be negative 4 plus 15, which is going to give me 11. Now I also need to know the magnitude of each vector. Okay, so just refreshing your memory on the formula here, since these are in component form, remember you can just do the square root of a squared plus b squared. So first component squared plus second component squared. So for vector u containing components 2 and 3, you would have 2 squared plus 3 squared. So that'll give me 4 plus 9, so that's square root 13. And now getting the magnitude for vector v using the same formula, you would have negative 2 squared plus 5 squared. So that's going to be 4 and 25, so I get square root 29. Now, taking this information and let's put it into the formula that I had up here just a few minutes ago. So I would have cosine theta equals, so the dot product is your numerator, and you divide that by the product of the magnitude. So that's going to be square root 13 times square root 29. All right, so if you do the 13 times the 29, we'll have 377. Now we're going to end up putting this in our calculator, so you don't have to worry about seeing if you can simplify the square root of 377. Okay, you will want to make sure that your calculator is in degree mode. That's how they're going to express your answers in this section. Now we're trying to find the angle that has this value, okay, or cosine of what angle has this value. So in other words, we're finding an angle. So if you remember, when you're trying to find an angle in your calculator, then you have to hit your second function first. So you would do second cosine 11 divided by square root of 377. So I don't need the parentheses there. Okay, so let's just say keep one decimal place, so that means that the angle is approximately 55.5 degrees. So if you were to draw these two vectors off, you know, like if you wanted to do a sketch of it and you were to draw these two vectors on the same coordinate plane, then the measurement that you're going to have between those two vectors would be about 55.5 degrees. Now, since this is a positive value, cosine's positive in the first quadrant, so that's why your answer here is somewhere between 0 and 90. So remember, you're either going to get something always between 0 and 180. Of course, like I said, this falls actually as a first quadrant because this is positive. So what you're going to see happen on this next example is that this is going to end up being negative, and our answer is going to end up being an angle that would fall into the second quadrant because cosine's negative in the second quadrant. But it's still going to always stay between 0 and 180. All right, so the next example, doing the same thing, we need to first of all find the dot product. So U dot V. All right, so take your first components and multiply those together, plus, and then multiply your second components together. So this is going to end up giving us -5. Okay, now I need the magnitude of U. So A squared plus B squared. So for U, that would be 2 squared plus 1 squared. So that's going to give me square root 5. And now do the magnitude of V. So that would be -1 squared plus -3 squared. So that's going to end up giving me 10. So square root 10. Okay, so now using our formula, we have cosine theta equals, so we'd have our dot product as our numerator, and then we multiply the magnitude, so that would be square root 5 times square root 10, so we end up with -5 divided by square root 50. Now you can simplify the square root of 50, but just like I told you a while ago, there's not any need to bother simplifying it because what we're going to end up doing is putting it in the calculator anyway. So to find this angle, and because we're finding an angle in our calculator, we would need to start off by using our second function. So we would do second cosine, then -5 divided by square root of 50. Now, because my value's negative, cosine's negative in the second quadrant, so I know my answer is going to be somewhere between 90 and 180. And of course, this one, you don't even have to round this one off. Your answer is exactly 135 degrees. Okay, one last concept that we're going to look at in this section, and it's looking to see if vectors are orthogonal. And it's almost the same thing as being perpendicular, and the textbook goes into some details as to what the fine details are that's the difference in orthogonal and perpendicular, but almost the same thing. So you're going to be asked to prove that two vectors are orthogonal. And all that you have to do to prove that is do the dot product of your two vectors, and your dot product must be equal to 0. And then that proves that. All right, so we've already done dot product. So here are my two vectors. So u dot v. So multiply your first components together. So 2 times -6 plus 3 times 4. So we have -12 plus 12. There's my 0. So if dot product turns out to be 0, that means these would be orthogonal. And again, if you did like a two-dimensional sketch of these vectors, then you would see that it's pretty much just the same thing when you look at it as being perpendicular.